All right, so the power rule for any positive number m, any logarithmic base a, and any real number p, log of base a m of p, we can just change that and basically pull the exponent out front, so it's p log base a of m. So logarithm of power m is the exponent times the logarithm of m. So all we're saying is that we don't need to have that power, we could just pull it out front. It's inevitably what's going to happen to it anyway. So for example, if we wanted to express these as a product, then all we need to do is just pull these exponents out front. So this would just be -3 log base a of 11. So we like this power a lot because it helps us get rid of exponents, especially if like our variable is in the exponent. It makes things a little easier to deal with. Once again, just as a reminder, I had said if you are an nth root of something, that's the equivalent of just being an exponent of 1 to the nth. So log base a of the fourth root is really just log base a of 7 to the power of 1/4. This is really just 1/4 log base a of 7. And then natural log, well, that's just going to be natural, oops, the 6 comes up front, so it's going to be 6 natural log x. All right. So using the power rule with the combination of your, what was it, product rule and quotient rule, take all of these, all three of these logarithms and write them in terms of sums and differences of logarithms. And we also want to make sure we don't have any powers. So we're going to try to do that as well. Okay, so based on what we saw earlier, pretty much anything that's multiplied, we're just going to have, put that back to green. If it's multiplied, then we just add. So log base a of x squared plus y to the 5th is just going to be log a x squared plus log y to the 5th. And then we were dividing inside of here by z to the 4th. So then we go minus log base a of z to the 4th. So now the next part is that we're going to just get rid of these powers. So we're going to pull them out front. So this is really just 2 log a of x plus 5 log y, or log base a of y, and minus 4 log base a of z. So for b, just as a reminder, that can be rewritten as log base a of a squared b c to the 5th, and that's all raised to the power of 1/3. So in this case, what's going to make a and b different is that we didn't have a power on the outside of all of this, so we were able just to do the split first. Everything in here has a power on it now, so we're going to pull this 1/3 out first. So it's 1/3 log base a squared times b over c to the 5th. I'll get rid of c here. I think we're going to need that little extra room. So the next part is we just break this up as we're going to have 1/3 log base a of a squared. Then we're going to have, once again, because we're breaking this up, so each one of these is going to have a 1/3 out front. Let me just go back a step and show you why. Because this 1/3 here, it's this log we're breaking up, so it's going to be log base a of a squared plus log base a of b minus log base a of c to the 5th. So remember, this is an a and that's an a. So we're going to have 1/3. And this is just going to be left with 2 now. Because what power do I put on a to get a squared? Well, it'll just be 2. So it's log base a of b minus log base, oops, sorry, we're going to pull that power out, minus 5 log base a of c. Almost finished with b now. So just fully expand this as much as I can. And now we can multiply by that 1/3. So we have 2/3 plus 1/3 log base a of b minus 5/3 log base a of c. All right. And unfortunately, I'm going to have to erase a so we can finish this out. So now if we do c, remember there's a multiplying that going on right here. So we're going to have log, so it's just log, it doesn't have a base. So we have log of b. So if we're multiplying this and this together, I can make it log of b plus log of a, y to the 5th, m to the 3rd, m to the 4th. We're going to have log b, and then this is going to break up even further, plus log of a plus log of y to the 5th plus log of m to the 3rd, oh, minus, because that was on the bottom, m to the 3rd is on the bottom, so that would be minus log m to the 3rd minus, because the n to the 4 is on the bottom as well, log there we go. Stuff's getting caused. I'm trying to do this. So because we got n to the 4th on the bottom, negative log m to the 4th. Now we just pull out the powers. We're going to have log of b plus log of a plus 5 log of y minus 3 log of m minus 4 log of n. So that would be the expanded form of c. Okay, so 11, take a minute and take this expanded group of logarithms or function of logarithms and try to bring it together so we just have a single log. Okay, so hope you had a chance to work on that. So remember that if I had a log and I had some sort of number raised to an exponent, I can bring that exponent out front. So what we're going to do is we're going to bring those exponents back in first. So 5 log b of log base b of x is now just going to be log base b of x to the 5th. We don't have any up front here, so this stays log base b of y. But we have this 1/4, which we're going to bring back inside. And that's going to be log base b of z to the 4th. So just again, as a reminder, if I have an nth root, it's the same as having the power of 1 to the n. I have 1 to the 4th, so I can take this back. So it's log base b to the 5th minus log base b to the y plus log base b over the 4th root of z. Now remember, if it's subtraction, it goes on the bottom. If it's addition, it's going to go on the top. So we're going to have log base b. So this is positive out front. This is x to the 5th. This is negative, so y goes on the bottom. This term is positive, so we get 4th root of z on top. And now we've put it all together in one logarithm. So number 12, you're going to use the rules that we had just established about products and sums and all that to try to go through this and figure out how you can break up these questions so that you can solve them. So given that log base A of 2 is 0.301 and log base A of 3 is 0.477, want to find log base A of 6, log base A of 2/3, log base A of 81, sorry, log base A of 1/4, log base A of 5, and log base A of 3 over log base A of 2. Okay, so the first two are a little easier to see in some ways. So we have log base A of 6. Just a second there. This can be considered looked at as log base A of 2 times 3 instead of 6, which we can rewrite as log base A of 2 plus log base A of 3. Well, we know what log base 2 is, or log base A of 2 is, it's 0.301. Log base A of 3 is 0.477. We add that together, we get 0.778. Excuse me. So the next one, we see that we have essentially a difference here because we got a log base A of 2 over 3. Well, we know that we can rewrite that as a log base A of 2. And then my denominator is a 3, so minus log base A of 3. So here we'll have 0.301 minus log base A of 3, which we know is 0.477. We're going to get a negative 0.176 for this one. Okay, so for C, we have everything is either a power or it's a 2 or a 3. So 81, sorry, I heard a weird noise for a second. 81 is just going to be 3 to the 4th. Well, we know that if I have a power here, that I can pull out that power. So this is just really 4 log base A of 3. So log base A of 81 can essentially just be, like I said, rewritten as 4 log base A of 3. And we know what log base A of 3 is. It's 0.477. Calculator here, so let me go with the answer back. That will end up being 1.908. Okay, so for our last ones here, for D, we got log base A of 1/4. So 1/4 is just 1 over 2 squared, which we can write as log base A of 2 to the power of negative 2. So we can rewrite this as negative 2 log base A of 2. So let me put it down over here again, but we said that log base A of 2 was 0.301. So this is just negative 2 times 0.301. Okay. So if we make an attempt at the next one, log base A of 5, I mean, the only way we can really break this up is log base A of 2 plus 3. And none of my rules apply to something of this scenario. So in this case, this is not something we can solve with the current information that we have. And then F, pretty straightforward. We have log base A of 3. We have log base A of 2. We don't actually have to do any work here. We know that log base A of 3 was 0.477. So we just have 0.477. And then log base A of 2 we had was 0.301. And this ends up being 1.5. Oh, quite a mess here. 5847170.8. Okay. So just bear in mind, most of these that we can work with by just rewriting things as powers or as products or quotients, with the exception of this case right here. We try to write it as 2 plus 3, our rules of logarithms do not apply.